Hello everyone and welcome back. So let's try out this problem here. Now, as a note, if you were watching this right at the previous example, I did simplify that previous example by removing the weight. One of the booms had a weight on it and I just made it a little bit simpler, did not have to worry about that. So if the numbers are a bit different than your textbook, that is why. But let's look at this one and see if we can solve it. Now, what's the first step in any of these problems? Well, it's to draw a free body diagram for your total complete system. So I'll go ahead and do that. Okay, so right here, got EY, EX, I have AX, AY, and I'm good. Now, how many equations of equilibrium do we have? We have 3. How many unknowns do we have? We have 4. And what do we do when that happens? Panic! Or we actually think about this a little bit more, because yes, this is a frame, which means that it has a multi-force member. What it does not mean is that all of the members are multi-force members. In fact, they're not all multi-force members. No, only this one's a multi-force member. This, and this are all simple two-force members. Because of that, we know the direction of the force that's coming out of them. And in fact, if I wanted to, I could say, okay, well, instead of having EX and EY, I'm going to draw this as a force like this. I call it E, and just say that I know the slope, which is going to be based on geometry. So rise of 4, run of 3. And that'll give me a hypotenuse of 5. Now, how many unknowns do we have? We have 3. Can we solve? Yes, we can. So let's try this out and see if we can solve this problem. Now, I've got 3 equations. No matter what, if you write them all down correctly, you're going to be able to solve at the end. It's just if you do them in the right order, then you can solve more quickly. You don't have to go back and do any algebra. I hate algebra. I want to avoid it if at all possible. You're like, you're a teacher. How can you hate algebra? I am just as allowed to hate algebra as you are. Maybe more so, because I have to do it more. Okay, but continuing onward. So, I'm going to take some of the moments around point E. If you're wondering why point E, it's because it's angled and I really don't want to have to deal with it right now. And AX is not angled, and AY actually points through this, so I don't have to worry about it. It makes it simpler in my mind. Okay, so moment of E is going to be equal to, well, I've got AX times the distance of 7, and that's going to be clockwise, okay? And then I have 800 times the distance of 12. And that's also going to be clockwise, which tells me I drew AX in the wrong direction, as always. And so that's going to make it 0. If I put this into my little calculator, what do I get? Well, I get 800 times 12, and then divided by 7. So AX comes out to be 1371. Okay. So I'll go ahead and draw that in the correct direction now. And I get 1371. Got 2 more equations, 2 unknowns. Now, I can either do some of the forces in the Y or some of the forces in the X. I'm going to do some of the forces in the X direction because I've got E right here, and it points partially in the X direction. And I only have that. That's the only unknown I have that points in the X direction. So because of that, I can save myself some pain and suffering. And I'm all about saving on pain and suffering. Who needs that? So let's calculate it. So I have, okay, AY plus, whoops, forces the X direction. What am I doing here? I have E times the horizontal component, which would be 3 over 5. So 3 over 5 minus 1371. That's going to be equal to 0. Okay, so I want to solve for E, so I plugged it in my calculator. And what do I get? I get 1371 times 5 divided by 3. And that comes out to be 2,285. So, okay, E equals 2,285. That would be kilonewtons. Okay, so that one's taken care of. If you're wondering how I knew what direction to draw that one, it's simply because I did this problem and I made a mistake and I had to re-record this video. So there's a reason that I actually had knowledge about that one, even if I messed up the first one still. Okay, now some of the forces in the y direction. As you see, I only get one of them correct. And that's going to be 2,285 times the vertical component, which is going to be the vertical component of my slope triangle over the hypotenuse, so 4/5. And from that, I'm going to add a y and then subtract 800. All that's equal to 0. And I will get that ay is equal to, calculator, can I aid? 2285 times 0.8 minus 800. So I'll get it's equal to negative 1028. Okay, negative 1028. Okay, so that's all my unknowns. I'm going to go ahead and change the direction on this one as well. 1028. Phantasmagorical. Okay. Now with that in mind, I need to solve for all the other forces. I know the force in pin A. I don't know the force at B, D, B and D. That's all that's left. And so you might be saying, okay, well, I gotta make a free body diagram up here, and you totally can if you want to. However, I like to get rid of B and D at the same time if possible. And it is possible. How is it possible? Well, it's possible because I can look at this point here and do my method of joints. Why can I do that? I can do it because this is a 2-force member, that's a 2-force member, and that's a 2-force member. So let's go ahead and erase some, and we will figure that out. Okay, here we go, and erase it all, just erase it all. Perfect, plenty of room. Now I'm going to redraw it. So I have my forces. And if you're wondering why I'm drawing them inward, I'm completely cheating and looking at the textbook to remember what direction to put these, because I always mess it up. Otherwise, I'm doing this just from step by step like you will be. Once I have it, I need to give their slope triangles, or their angles. I only have slope triangles in this case. So that's 4, 3, 5, and that's force BD. This is 4, 3, 5, and this is 2285. And this one right here is going to be force AD, and it's got a slope of 1, 1, square root of 2. Wonder where that came from? It's simply that it's 3 and 3. I went ahead and divided everything by 3, just to simplify things. Now I have to set my equations, and I'm going to have to do algebra. I can't actually escape algebra this time. Algebra will find you one day, no matter what you do. It's like the boogeyman. Okay, so let's try this out and get this solved. So first off, sum of the forces in the x direction is going to be equal to the x component of force AD. Okay, so that's force AD times the horizontal component over the hypotenuse, so 1 over square root of 2, minus the x component of force BD times the horizontal component, which is horizontal component of my slope triangle over the hypotenuse, so 4/5, plus 2285 times 3/5. That's the horizontal component. Okay, I can't solve that. Two unknowns, one equation. So let's make a second equation. So some of the forces in the y, very similar, but I have to use the vertical components now. So for force AD, it's going to be the vertical component over the hypotenuse, and it's pointing down. Force BD is also pointing down, and the vertical component would be this one right here over the hypotenuse. That's 3/5 now. And then it's still plus 2285, but its vertical component over the hypotenuse. And there we go. Now, if I solve these, what do I get? Well, I get that my force AD is going to be 646, and my force BD is going to be 2285. Now, if it throws you off that both of these are 2285, you should realize that this shape is completely symmetric. It's actually, if I were to have angled it and made this my y-axis, and then this my x-axis, you would see that these are both angled exactly the same, and so they would have to be equal to keep equilibrium. So it's one of those things that you could have actually solved this a lot simpler if you had just switched our axes. I didn't do that because you might not think to do that, and it's a little bit more difficult when you have slope triangles like this. But it's there. It could help you. Now with this, we actually know all the answers. We know the force at A, we know the force in AD, we know the force at BD, we know the force in ED, we know the force at BE, we know it everywhere. We have solved this problem. So well done. Thank you for listening. I hope this helps you. Just remember, be very careful, break everything into components, and you can solve these. Just equations of equilibrium over and over and over again. Okay, I'll see you all later. Have a wonderful day. Goodbye.